Anyways, thanks for coming. It's excellent to see you all here. I'd like to first thank the entire crew. Most of everybody's here. We got a new mule this year and tried to test out the suspension on, so it's now back in the shop. But everything that we do takes a lot of effort, and want to send praise to an absolutely amazing staff that have made it for an awesome, enjoyable season, and hopefully some good data that we can pass on to you in the next couple of days. So this is actually, I've got a small little farm, and this is my hook for the first presentation. This is my own beautiful canola field that I just bought the land actually this year from my dad, and decided to spend a whole schwack load of money putting actual drip irrigation into 110 acres. So really excited for a great year, but then we started to have all of these really nasty looking clouds and lots of storm. So then we have this little monster that comes in and decides to wreck everything. So I ended up with a 58% hail claim. So this hail thing has become personal for me. So I'm after it. And luckily, I did actually take out some insurance this year and might have had the best year I've ever had. But hail in general is actually a pretty difficult thing to study. And I've been hearing from it from farmers. And it was really a lot of the sales people that were touting these hail rescue products that drove the interest in studying hail. So farmers are saying, well, I've been hearing that I can spray this magic product that will help our crop recover, because it's really kind of a Florence Nightingale effect when you have this beautiful field and you get damage and you want to know, is there anything I can do to sort of save that? So some of the more important things that we sort of struck out to study within this project is understanding the effects of the timing of hail. So we can look at a calendar date, but really what's probably more important is the crop stage that it's at and how much recovery period you have. So what are the growing conditions like, and how much time and heat units do you have after that event to allow the crop to recover? Within that, we looked at a couple of crops. We looked at wheat within 3 stages. So we looked at tillering, heading, and flowering. And for peas, we were kind of the 4 to 6 nodes, flowering and potting. And we also studied dry beans. I'm not going to present on them today, but we did look at them. Another important factor that we wanted to look at was how heavy of a hail was it. So in this case, again, we chose to look at 3 different levels. None, which is kind of tricky when you're trying to control a hailstorm. And we wanted to look at sort of a light hail and a heavy hail. And in this case, we just picked some numbers arbitrarily, so 1/3 and 2/3, basically based on defoliation. And the third factor is that recovery treatment that I mentioned. So in wheat, we looked at no treatment, a product that actually had a hail claim on the label. So for wheat, we looked at an Alpine G22, and we wanted to include a fungicide. Fungicide, in this case, Procero has Fusarium head blight activity, so I thought that would be important to look at. For peas, again, we looked at no treatment with another hail claim, and we just sort of arbitrarily, again, picked a different company that had a different product, in this case, ATP relief plus some magical boron. And in this case, the fungicide headline. Now, this is one that there's a lot of anecdotal stories out there that the strobulins have done miraculous things to help recover a stressed crop. So we wanted to really include that one for sure. And then dry beans, we looked at none, Omex P3, and in this case, a bacterial side, it's Parasol. So there is evidence that physical leaf damage can actually incur saprophytic bacteria. So this one we were quite interested to see if it made a difference. So Greg talked about risk. I kind of like risk, maybe not quite as much as this fella here. But watching these hailstorms, I'm new to hail insurance as well. So I bought the crop insurance with the hail rider. But then after watching storm after storm, I said, okay, I got to go buy some more insurance. And lo and behold, the next day, I made the 24-hour period, major hailstorm. So we have our WhatsApp, we on crew, we communicate with each other, and I thought, well, I better show off my hail. I mean, everybody likes to share their grief. And, well, Lewis over there, he had to one-up me like he usually tries to. Sent me his picture. We both got new roofs. He got a new car. And then went and wrecked another one with a deer. And then we had a really kind of humorous summer student who really needed to get in on the action and sent this one out. That's for Ben out there. But the truth is that, not all hail is created equal, and it's an incredibly variable thing. You will never get the same type of hail even across a field, so inherently in a field scale setting, it's very difficult to study. And that's when I experienced hail myself and sought out to all of my connections with the industry, there's really no one out there that knows what the hell they're talking about when it comes to dealing with hail. So good opportunity, and I have to give kudos out to the Pulse Commission because they were the first to step up and fund this project where we could develop an actual hail simulator. That way we had some control. Researchers are control freaks, right? We have to control everything so that we can have confidence in what we're testing. So we developed this simulator here. And Mike and Jamie and I, we had a lot of fun all summer beating the crap out of our plots. We tested this out, and a lot of the ideas came from our friends up at Innotech in Alberta, where they were working on hail with AFSC quite a bit, found out that a dog chain worked really well at simulating hail. We're pretty lazy. I'm lazy, so we mechanized it. And turns out, when we brought in the hail adjusters to look at it, they said they agreed that it did a really reasonable job at simulating actual hail damage. So this is just a shot. It's different. Obviously, every time that you have a different type of crop, a different thickness, we had to play around with our hail machine to hit the levels that we were trying to achieve. So seems like everybody wants to one-up me all the time. So this is actually Rod's hail machine in Vegreville. He had to attach golf balls on the end of his chains, and kind of looks like a mean machine here. So we actually have this study in Vegreville and with a third partner up in Falher. Yeah, that's kind of more like a rototiller rod, but I think mine's prettier than his. His might be safer. Safer? Now those golf balls flying off. And that's just a quick shot of our simulator up in Falher with SARDA. So after watching that video of Rod's machine, I sent him an email. I said, Rod, you're going to be known as the man who made hail. And he turns around and sends me this picture. It's an actual Greek god of the eastern wind, and he's holding a bucket of hail. And you can see underneath there, it says something like Keke. So, but he says it's pronounced kick-ass. So now his name is Rod the God Kick-ass of hail. So I had to share that with you guys. We had the opportunity, once developing that simulator, to test it out on a canola project, and this one was really just looking at the impacts of hail damage in canola recovery, and was really only focused on the timing and the levels of hail. And you can see, usually what we would start off with is do the 100% hail damage with our machine. It would take, 6 passes to get complete defoliation, and then the way we got our other levels was simply, doing fractions of the number of passes. But I think we did a pretty reasonable job in getting some differences in defoliation. The results from last year actually show, on the left here is our check plot, and that's the beauty of having a hail simulator, is we can actually compare it to what would have happened without any hail, and you can't normally do that in a real life scenario, and which is why it was always been tough to test any of these products or strategies involved. So in early timing, you can see as we move down our levels, even with 100% defoliation early on, we're still at about a 50% yield. Whereas even a week later, it's dramatically dropping the chance that crop has to recover and give us a good yield. So what we've been learning in the short term really is the timing of the hail event is the most important factor. And the level is actually probably not as important. Our results from this year with that same study are showing very similar trends, so I think we've done a good job at sort of verifying that the simulator works well. In this case, we actually had 5 timings, and the spots down here where we had no bars, essentially the crop was too far delayed and we weren't able to actually harvest it. So there was a zero yield. So now that we've got the machine sort of tested and validated, we're moving on. This was our first year studying wheat, peas, and our dry beans. And this is just a shot of our wheat study at the earliest timing, June 15th. So for most of our timings, there's about a 2-week difference. We did kind of June 15th, July, or June 30th, and then a July 15th. And then the 2 damage levels are sort of demonstrated in that picture. When we look at an overhead shot, these are how we designed our trials. Now we actually have 4 replicates, and we left a little space in the middle there so that we could get the tractor in and do our damage levels. And then our first replicate here is not randomized, so you can actually see what happens. This picture was taken July 22nd. We'll have the first bit is checks where we didn't do any damage, and then you can see where there's little tire tracks in there that we did do the damage. But overall, that early hail time frame you can see is quite green. It seems to have recovered and grown well. Even 2 weeks later, and you'll notice these 3 are the checks, and then we'll have a light with the 3 treatments, and then a heavy with the 3 treatments, and obvious more damage, and then our late timing as such. Again, it just doesn't have the chance to honestly recover. So this is the results from our Lethbridge study, and that's only looking at the damage. So we have a lot of checks within this trial, but you can see here it goes from 0, that's no hail, our light hail, and our heavy hail, and with the various timings. So at our early timing where we're tillering, we beat the crap out of the wheat and honestly didn't really impact yield at all in wheat. Whereas we moved just 2 weeks to sort of an early heading type stage, we went from close to 6,000 kgs per hectare and dropped it just about in half with just a light damage. And interestingly enough, our heavy damage honestly didn't result in the same level of yield loss. When we got to our later stage on July 15th, the yield was cut in half, but we're not seeing the difference within our damage level. So with a late hail, the amount of hail seems to not be as important as the timing. So somewhere between June 15th and June 29th, there was a critical point in the crop growth where damage was basically irreversible. When we combined our data with our friends in Falher, we saw very similar trends and very consistent results from both. So basically, we're getting a handle for what happens to a crop with the different timings of hail. Maybe we can do some more fine-tuning to find out where that magic drop-off point. I think the importance of this information is that if we're going to do anything, we need to understand what are our chances of recovery, what type of crop are we dealing with, and it might actually add a little bit of information whether it's worth investing anything in it. When we zero in the actual rescue products, this is our zero hail. So we thought that it's pretty important to be able to say, was there a response to this product without hail? And that's what this slide is about. Within our error bars, you can see that there's really no difference with our mid and our late timed hail. There's a small, I think, a chance that we'll see a statistical difference between our early stage. So that comes down to when is the proper time to be applying these products in the first place. So for example, fungicide at flag leaf type idea. In this area, we're actually getting beyond where a treatment would do anything at all. So we actually potentially saw a response from both the nutrient product and the fungicide with no hail at all. So keep that in mind. When we move to our light hail damage, and these are all on the same scale, so I can kind of go back and forth, you can see what happens to the yield. This one diminishes small and then obviously progresses rather drastically within that 1 month time period. Again, probably no difference in the products at our mid and our late timing, but a potential response at our early timing. And moving to the late hail, I can kind of toggle between these two. You can see, again, most of the loss is coming with our later damage with the heavier hail, but in all honesty, not a big difference. In this case, we're not seeing really any response in anything. So keep in mind, this is just one site year of data, And we're going to be doing this over the next few years that will help determine whether any of these responses are real or not. So we'll move into our peas, and this is just an overhead shot, and I wanted to send a shout out to AGM Seeds for doing all of our aerial photography, so thanks for that. The peas, this is again just looking straight at the hail damage. Now in this case, a little bit different than the wheat, at our early timing, June 15th, you can see we had a major drop in yield, even with our light damage, and not a real big difference with our heavy damage. So that would sort of lend to showing that pulses or peas in particular might be a little more susceptible to significant yield loss at an earlier timing. We might need to play around with this a little bit, but it's just, I think, important to understand. As we moved on to our mid and our late, again, pretty dramatic yield losses, and each time we had its own check, so that's why these bars are different. When we go into the responses, again, error bars are fairly big. I don't have a tremendous amount of confidence in this data yet. I'd like to get a few more years under our belts. But numerically, potential response to fungicide, likely not statistically significant. So in this case, where we were sort of hoping that these anecdotes of amazing responses to headline would show up, we saw a glimmer, but not anything near the stories that I've been hearing, especially from Doug Rodaway. You're a liar, man. Just kidding. We'll find out next year. Maybe you're right. So again, as we move to the next date, you can see how much the yield is impacted with that light hail, even early on. So dramatic yield losses. No statistical differences probably between any of these and the treatments in the early timing. Interesting, we have a bit of a boost with the nutrients in the mid timing. Not too sure there's a potential response later on there, but I think truthfully the jury's still out on this one. And then with a later damage, not really seeing much of anything, just that the crop was hurt really badly by that hail. So that's actually bringing me to the end of the hail talk, and I'm going to move on to the next one, but I'd like to open up the floor to any questions I'm not sure I can answer, but I'll try my best. Is there any questions on the hail studies?
So you just talked about the responses for data from SARDA?
Yeah, we do have the data. Some of the SARDA data really does look like it corroborates with our data. Haven't had the chance to really dig into all of the Vegreville data yet, but looking like we're all really good at making hail anyways. Yes, John?
So, Ken, are you working closely with AFSC on some of this?
Yeah.
So that they can simplify, like, for instance, your stuff just between canola and peas. Sometimes they can learn a little bit from that.
Yeah, and I think that's actually what drove the first initial interest in it was the Vegreville folks were actually trying to help train adjusters from AFSC. AFSC has been very cooperative in the project. In fact, they're funding the canola project. Canola is actually a newer crop. We don't have the same level of information that we do on others, so they wanted to get a better handle on canola recovery. Little fuzzy on where they get all of their data, but at least now we're helping generate some for them. I think they've been involved in coming and rating our plots so that we can get their predictions to yield loss compared to our actual. And in the study from last year, I actually did plot out their predictions, and I have to say I'm pretty impressed. Their predictions are a lot better than you might think. So I think there's ways that we can tweak it, and I think there's also ways that we can have tools as farmers armed with information that might be able, to be used to negotiate with adjusters, because sometimes adjusters are old timers that have been around forever and know their stuff, and sometimes they're brand new, and sometimes they're retired cops, I've been finding. So, yeah.
Are you tying in irrigation timing
In our plots, we did put them under irrigation only to hopefully simulate kind of that rainfall event that does come with irrigation. Sorry, the question was irrigation. That's only being done at our Lethbridge site, but otherwise there's no real tide irrigation at this point. We do, this is sort of a scratch at the surface for the first time, but we do have the ability now to learn. Like, this is kind of just broad. We're going to see if we see anything, and then we can zero in on some other things. Don? So the actual cold part of the stress, to me, the question was, does the cold of a real storm, is it going to be a lot different than our simulation? Is a real storm going to be different than our simulation? Absolutely. My thoughts are, though, that a stress is a stress, and it's probably more the actual physical beating, the bruising and tearing of the crop that's probably the bigger rider than some temperatures. Would there be some differences? Yeah, but I think that being able to control the environment is going to allow us to pick out winners and losers, essentially. All right. Yeah, that's usually something we like to do. Of course, it seems that the economics within every farm tends to be different, but we do plan to do a full economic analysis to the best of our ability to help shed some light with the outcomes, yeah. I'm going to move on to the next topic, and this is another study that's been pretty exciting and fun to be part of. Again, learning about something new. For me, moving into row crops is kind of new and exciting. And in particular, we've been hearing, Pioneer and Monsanto are making pretty huge predictions of expanding dryland grain corn acres across Western Canada. So we saw it as an opportunity, if this is happening on the breeding side, that we'd like to be part of the agronomy side. So how do we fit grain corn production, for example, into zero tillage? If moisture is one of our limiting factors, we want to make sure that we can fit this into our rotations, that we can do it in a one-pass seeding system, and basically learn the agronomy of producing corn, because it's something new to a lot of us. So within that, we were lucky to have a study funded by ACIDF and a little bit of help from Pioneer. We were looking at a number of studies, and we actually have a lot of locations across southern Alberta. We're working with Ag Canada, with Dr. Brian Barris's crew, and with Dr. Manjula Bandera out of the Crop Diversification Center in Brooks. So we've got locations in Lethbridge, Vauxhall, Bow Island, and Medicine Hat. So this is a really good southern Alberta project. We're looking at plant population and row spacing. We've got a nitrogen fertility study and a crop sequencing study, and I'm just going to share our first year results with you on some of these. So I mentioned we had purchased a monosem planter. This is one that's actually rigged up to do a one-pass seeding system. There's Yetter cleaners in front of the opener. There's side banding disc openers, so we've got a liquid tank up here to put phosphorus with the seed. We're side banding our nitrogen fertility, and then we're planting, and we're just playing around with the row spacing configurations. For those of you that don't know anything about vacuum planters, they're actually very cool. They are on a parallel link system. They have a vacuum that sucks these individual seeds onto a plate. So now you're actually very precisely taking one seed and within a defined space and population, just dropping it down very evenly. Mike's going to talk to you about our canola project using this planter tomorrow, but my first year's experience with this planter, it was definitely a learning experience, but I have to say I'm really impressed with the job that these planters do, and I think we have a few things to learn from them. So we also had to build probably the ugliest research corn planter in the world. But this was just a cone seeder, so we could do some variety testing as well. We just modified with some John Deere planters, and we're not even using the vacuum side of it, but it still has the benefits of the parallel link and such, so we use that one for our variety trials. And we also got a really... interesting corn header for our ugly plot combine. I don't know what the colors is in research, but so it's kind of fun. We were able to go out there, and on this combine we've got a yield monitor and a moisture and a test weight scale, so that's how we're collecting our grain corn. And I think we were harvesting right up till about the 15th to 20th of November this year. Managed to get everything off rather nicely. So population and spacing I think is important. When we're walking across the video, you can see the different spacing between some of the plants. Sometimes they're very sparsely spread out. It all has to do with seed bed utilization, canopy closure, optimum capture of sunlight, all very important things. And we really need to adapt this to our climate, our faster growing seasons and such. So that's, I think, why it's important. In this picture, you'll notice like even the plant growth habit is dramatically impacted by row spacing and plant populations. You can see here they're much smaller than over here. So we did notice visually big differences. And we ended up, even with dryland type conditions, pretty reasonable crops. And have to say, kind of impressed with the yields of the corn given the conditions that we've had the last couple of years. So this is the sum data. This is 5 site years of data, and this is the big comparison between the 20-inch row spacing and the 30-inch row spacing. When I spoke with folks, scientists like Dwayne back down in South Dakota, he says, Ken, you're going to want 20-inch row spacing and 20,000 seeds per acre. Interestingly enough, the 20-inch rows, this is the blue line, has been out-yielding our 30-inch rows. Again, probably due to the type of environment that we have. But I think what's striking to me more than anything is that as we're moving up our planting population from as low as 15,000 kernels all the way to 35,000, is that this slope still seems to be going. This is, I think, kind of bad news for farmers and good news for seed sellers. But I'm kind of shocked that we haven't seen the peak that we were expecting, and we'll have to watch this carefully. But in this sense, we've been seeing a pretty marked improvement with yield with planting populations. Now, as you mentioned earlier, economics is going, when we throw the economics into this picture, likely this is getting a little bit pricey for that hybrid seed on a dryland scenario. But kind of still guessing optimum is probably between 20 and 25. Maybe a little bit higher, but we'll wait to see with some more environmental conditions. So our nitrogen study is kind of a basic nitrogen study, and we also had some in-crop fertilizer, our liquid urea treatments as well, and that's Cam doing a good job burning our corn. And funny enough, this is the biggest surprise to me of anything, is we had pretty much no response to nitrogen. So even at our 0 levels. And this is across 4 trials, sorry. The background nitrogens were 113, 13, 66, and 21. So there were a couple of sites that had really low background nitrogen, and we still didn't see any response. So we talk about adding, products. I'm kind of hard pressed to see a response to nitrogen here. We were not sure if the decrease on this last one was due to actual harm from us spraying the urea on it. We will be building a better system for applying that liquid fertilizer, so we'll avoid leaf burn. So kind of a drop tube side-banded approach as opposed to just the straight down streamer bars that we were using there. But anyways, something to keep in mind. But we're hitting close to 80 bushels an acre of dryland grain corn, and I think that's exciting. I think that may work in some scenarios. Our crop sequencing study was basically a mini rotational study. So what do you grow corn after? And in this case, we grew a whole bunch of different crops the year before, and then planted corn into that same plot. And this is an overhead shot of how that looks. So we had mustard and canola, wheat, peas, soybeans, corn, and lentils were the precursor crops. And this seemed to have a much more of an effect on our corn yields than the straight nitrogen fertilizer did. We saw this earlier in the year, but the mustards, the brassicas, the corn didn't look too good in it. And it was kind of purple and spindly, and it did actually equate to a yield reduction. So statistically, I'm guessing that these three crops here, mustard, wheat, and canola, were definitely lower yielding than at least our soybeans, corn, and lentils. So interesting that corn did so well after corn. You kind of, this is maybe why the folks down south are growing so much corn on corn. It didn't seem to have any kind of yield reduction, but again, this is just a 2-year cycle, so it's not really telling the full picture. I mentioned earlier the corn after canola. This is what it kind of looked like, and from what I've been told, it's because canola and mustard are non-mycorrhiza crops, and now that means the year after, when that corn needs that mycorrhiza for phosphorus uptake, that it's actually phosphorus starved. Now, we did have phosphorus with the seed in this case, and still saw that effect. Maybe we need a little bit more to compensate, but that would be another study. Within that study, we also thought it would be interesting to, how do you deal with the residue? So we actually had 2 parts to that treatment. We had tillage before seeding, so we actually dealt with that residue, and then we had a no-till scenario. And this is just all of the data put together, but we did actually see a 5 bushel per acre increase with the direct seeding. And I think that kind of makes sense, but I'll be curious to see if that follows through. And I suppose it's going to be different with different years and different moisture levels. A quick shot of our variety trial. I'm not going to talk about it that much, but there's probably a big group of varieties down here that were out-yielded by this top group here. I don't know much about them, but my guess is they are the lower heat unit varieties. Making maturity is probably the most important thing in choosing the variety in that sense. And that is all I have. So thank you very much for your time. I could take a question or two on the corn, but I think I'm over time probably, right?
No, you got time.
I feel over time. No questions. John, sorry. Go ahead.
Ken, your nitrogen corn thing seems a bit unbelievable. Was moisture the limiting factor in all locations?
We were definitely in a dry situation in the spring, and I think that could have played a factor, because I think sometimes when plants are stressed early on, that their yield potential is set. So even with that good moisture that we had later in the season, it just maybe didn't take advantage, although I'm still kind of, on a dryland situation, happy with 80 and 90 bushel corn. Medicine Hat this year had fantastic corn. Last year, not so good. Yes?
Just following up on the nitrogen question, Ken.
Yeah.
So, corn about 1.1 to 1.2 pounds of N per bushel. So take a 60 bushel to 90 bushel crop, 1.2. You're going to see a response to the other 100 pounds? Likely not.
So in that sense, it makes sense to you.
Yeah. If not so completely, I mean, we're talking about corn varieties that have 6 times more potential than what we're seeing in that slide in a lot of cases. 300 bushel, maybe?
Okay.
So to see that end response, you got to bump the yield up, and we're kind of cruising on the bottom of the yield.
Yeah.
So, it's like anything. If you're looking for high performance, then high input. If you're, because of our climate, we're kind of be on the extreme performance. So makes sense.
And we might actually have sort of this thought that corn is such a huge nitrogen scavenger, but at these yields, our soils are actually more than capable of fulfilling its needs. Yeah. Was there any more questions?